This is an experiment to make diesel fuel out of blending vegetable oil with a series of solvents. The solvents I've chosen are petrol or gasoline, acetone, denatured alcohol, turpentine, witch hazel, ethyl alcohol, isopropyl alcohol, and wintergreen. And this is a dozen mason jars that I'm using as beakers. And the nice thing about them is they have reclosable lids, so I can put my sample in there and close the lid and leave it for a while if I want to. Plus the jars are graduated. All right, so this is 600 milliliters of waste vegetable oil that was settled and screened with bug screening. And now I'm going to put into it so it's 600 milliliters, and I'm going to put another 100 milliliters or so of witch hazel into it. Well, I'm not going to put that much. As we can see, the witch hazel is not dissolving into the vegetable oil. It is, in fact, just settling out the bottom just like water. So witch hazel is not going to help us as a solvent. Okay, this is 600 milliliters of WVO, and I'm going to pour in about 100 milliliters of 70% isopropyl alcohol with wintergreen in it. Well, I don't think I'm going to put that much in because, as we can see, it isn't working. Now, the interesting thing is it's floating on top. Now, this is 600 milliliters of the same WVO batch that is going to be receive some 91% isopropyl alcohol. And as we can see, isopropyl alcohol is floating on top and is not dissolving into the vegetable oil. This is WVO with denatured alcohol added to it. And as you can see, the denatured alcohol is floating on top of the vegetable oil. This is 600 milliliters of waste vegetable oil, and I'm now going to add ethyl alcohol or grain alcohol at 100%. And as we can see, the 100% ethyl alcohol is floating on top and not dissolving into the waste vegetable oil. This is a jar of waste vegetable oil, otherwise known as WVO, and I'm going to put some gasoline into it to see what happens. As you can see, the gasoline dissolved readily into the waste vegetable oil. You can see, I don't know if you can see or not, but there's some swirling, but eventually those particles will dissolve readily into the vegetable oil. This is waste vegetable oil with gasoline added to it at about 20%. And again, there's no apparent precipitation at the bottom of the jar, and there's also no separation of the two fluids either. 24 hours of sitting together in the blend. This is a mason jar with about 600 milliliters of waste vegetable oil in it, and I'm now going to add about 50 milliliters of acetone to it. At first you can see that there's a swirling difference of fluids, but as we wait, we will see that those differences will slowly but surely separate. The separation of those fluids will stop to exist, and they become a uniform solution. This is waste vegetable oil with acetone added to it, and it's set for 24 hours, and there's no apparent precipitation at the bottom of the jar. This is waste vegetable oil with pure gum turpentine added to it. And as you can see, it's dissolving into the vegetable oil. I'm going to pour a little bit more in. There we go. Okay. This is a blend of waste vegetable oil and turpentine. They have been sitting together for 24 hours. There's no apparent separation of the two fluids, and there doesn't seem to be a precipitation at the bottom of the jar. So we found 3 solvents that will dissolve into vegetable oil readily. Gasoline, or otherwise known as petrol, will dissolve readily into vegetable oil. Acetone will dissolve readily into vegetable oil. And turpentine will dissolve readily into vegetable oil.